We're going to try one more oxidation reduction reaction. This one's going to require a little bit of thought. A little tougher one than normal. P4 plus water will produce PH3 plus H2PO2. It is a little harder, but the process is the same. We need to make sure that the electrons are balanced. So this phosphorus, since it's all by itself, has an oxidation number of 0. Here's a compound water, so H is plus 1, O is minus 2. So the sum of those atoms add up to 0. H is plus 1, P is minus 3. And H is plus 1, O is minus 2. In this case, the P is plus 2. Every compound there adds up to 0. So now I want to try and balance this. I want to find out what changes oxidation numbers. It looks like my phosphorus goes from 0 down 3. And the other thing that changes is the phosphorus that goes from 0 up by 2 electrons. So the lowest common multiple between a 2 and a 3 would be 6 electrons. And I get that by having 3 of these and 2 of those. So one would think I want to have 2 here and 3 there. Well, what do I do with my phosphorus on the left? I can't have 5 on the left when there's a 4 there. The lowest common multiple between a 5 and a 4 is 20. So if I put 5 here, that just means I've got 20 phosphorus on the left. I need to get 20 phosphorus on the right. Well, how can I do that? Well, from above, it looks like I need a 2 to 3 ratio. So I need those 2 phosphoruses to add up to 20 in a 2 to 3 ratio. And the best way to get that to happen is simply by having 8 of the first one and 12 of the second. This will reduce down to a 2 to 3 ratio, and the sum of those does give me 20. So if I change my 2 here and my 3 to an 8 and a 12, I think I end up with the 2 to 3 ratio that I'm supposed to have. So let's see what I really have now. I've done a lot of messing around with stuff. So I currently have 8 of these phosphoruses right here instead of 2. Well, 8 times 3 is 24 electrons. These phosphoruses, there are 12 of them. So instead of 3, I actually have 12. Well, 12 times 2 is also 24 electrons. So I think my electrons are balanced. Let's go ahead and just double check everything. I've got phosphorus, hydrogen, and oxygen. On the left, there are 20 phosphorus. And on the right, there's 8 plus 12, which is 20. On the left, I currently have 2 hydrogen. And on the right, I have 24 plus 24 is 48. So to balance that, I'm going to have to put a coefficient of 24 here. That gives me 48 hydrogen. But it now gives me 24 oxygen. On the right side, I have 12 times 2, which is 24. So that actually worked out okay. As far as figuring out the element that was oxidized and reduced, well, the phosphorus went from 0 up to plus 2, so it was oxidized. And phosphorus also went from 0 down to negative 3, so it is reduced. So in this case, some of the 20 phosphorus on the left reactants were oxidized and others were reduced.